So today we're going to be coming back to the topic of polynomials. I know we started to move on to, in particular, the quadratic polynomials. But we're going to come back and go look at this beginning topic again, so we know everyone is got a good solid base before we move forward into the next topic. So we're going to be creating equal problems. We're going to be looking at polynomials, combining terms, and creating equal expressions. So the state standard is being able to see structure in expressions. So we're going to look at expressions, and then we're going to determine their structure and then the process in which we need to work with them. All right, so here is our first problem. I'm going to demonstrate it for you. We have, if we're looking at our expression here, we can see that we have two binomials. We've got x minus 2 times x plus 4. Now, when we do have two binomials that we need to multiply, we can use the FOIL method, which stands for using the first letter of all four words, leaves us with FOIL. We've got the first term, then the outer terms, the inner terms, and then the last terms. That's how we're going to multiply. And then we combine like terms. So let's go through this. I'm going to lead us in this example. So the first terms are x and x. So we've got x times x gives us x squared. X to the second power is another way of phrasing that. And then we've got our outer terms, x times 4, which leaves us with 4x. We have our two inner terms, negative 2 times x, which gives us negative 2x. And then we have our last terms, negative 2 times 4, which is negative 8. So I like to say add like terms, but you can just say combine like terms. You can see here that I've got 4x plus negative 2x. And the reason I do that is so that I don't end up misplacing a negative sign. So it is the same as saying 4x minus 2x, which leaves us with 2x. So now we have all three of our terms. We've got x squared plus 2x minus 8. So if we look at this expression and we want to identify it, if this were set up as an equation, set equal to 0, remember with the quadratic equations that we talked about before, this would be a quadratic equation because it's x to the second degree. So now we've got our equal systems, our equal expressions. Remember our state standard, we're going to be identifying expressions here. So x minus 2 times x plus 4 is the same as x squared plus 2x minus 8. So now I have it stated here as independent work because you're going to be doing this, but we're actually going to be doing it together. We're going to walk through it together. So here I have the same starting binomials, 2x minus 1 times x plus 4, and we want to determine which of these equations is true. So you're going to be showing your work. You're going to be working through it. But we're going to be doing it together at the same time. Remember, we're practicing the FOIL method because these are two binomials. We can do the FOIL method, first, outer, inner, and last. All right, so let's, you guys had a moment to work through it on your own, so now we're going to look at it together. So we've got 2x minus 1 times x plus 4, and it is the second answer. That is the true one. So you guys have done a great job with that, identifying the mistake that was made in that first one. Had to do with the combining of like terms, so great job with that. So the correct answer is 2x squared plus 7x minus 4. And let's walk through the steps together. So we have our first terms, 2x times x leaves us with 2x squared. Our outer terms, 2x times 4, leaves us with 8x. Our inner terms, negative 1 times x. And I love how you guys had in your work, you kept the 1 there. It really makes a difference when we're combining the like terms, preventing mistakes. So great job with that. We've got negative 1x. And then our last terms, negative 1 times 4, which leaves us with negative 4. So we combine our two like terms, our x to the power of 1s. We've got 8x minus 1x leaves us with 7x. So your final answer that you guys did a great job coming to is 2x squared plus 7x minus 4. Great job with that.